Today we're going to learn proof by contradiction. Another name for that is called indirect proof. You will learn why it's called proof by contradiction in a minute, but let's talk about what this is first. Who would like to read this for us? How about me? Somebody haven't called over here. Jet.
Until now, the proofs you have written have direct proofs. Sometimes it is difficult or even impossible to find the direct proof. In that case, it may be possible to reason indirectly.
Okay. So what we're saying here is sometimes proofs you may not be able to prove them directly. Okay, using two-column proofs and things like that, right? So we're going to learn another way of proving. Okay. Statements. Okay. Conditional statements. So who could tell me then? Read on here. Indirect reasoning is what? Go ahead, Jason.
Indirect reasoning is commonplace in everyday life.
Suppose. Yeah. Go ahead.
Suppose, for example, that after walking home, Sue enters the house carrying a dry umbrella. We can conclude that it is not raining outside. Why? Because it is. We're raining to enter umbrella with wet.
Okay. So someone would say, what if she was in the car? Okay, that's not what we're talking about. But you know, there are many what ifs. But you know, this is the idea, right? Indirect proof, right? This is indirect reasoning. This is an idea of indirect reasoning. So, like I said before, indirect proof is used when you can't prove something directly. And how do we do this? Well, here is what they're telling us. Who wants to read what an indirect proof is? Go ahead, Brianna.
In indirect proof, we begin by assuming temporarily that the desired conclusion is not true. Then you reason logically until you reach a contradiction of the hypothesis or some other known fact. Because you've reached a contradiction, you know that the temporary assumption is impossible, and therefore the desired conclusion must be true.
Okay, so yeah, you're like, what does that mean? Okay, so we'll do some examples. Let's see if it makes any sense to us. And we're going to summarize this for you in a minute in 3 steps. Is that okay? All right, Brianna, keep reading.
The procedure for writing an indirect proof is summarized below. Notice how these steps are applied in the examples of the indirect proof that follow.
Okay, so what we just said about this indirect proof is summarized right here. Simple 3 steps. Write this down. This is what you need to write down. First, how to write indirect proof? First, you assume temporarily that the conclusion, not the hypothesis, okay? You assume temporarily that the conclusion is not true. Second step, reason logically until you reach a contradiction of known fact. Third, you point out that the temporary assumption must be false and that the conclusion must then be true. So write this down and we'll do an example and we're just going to blindly follow this at first. And as we do this, hopefully it'll make sense to us why this proves the statement that we're trying to prove. Okay, go ahead, write this down. So let's do an example. Right now, you may be saying, well, it doesn't really make sense to me, but let's just blindly follow through and see whether or not we could prove an example like this. No, this is in the book, just follow along, okay? And then I'll show you which ones you need to write down. So given n is an integer and n squared is even, we want to prove that n is even. Okay. Right, so can you imagine trying to do this as a 2-column proof and things like this? Okay. So we're going to use this method called proof by contradiction or called indirect proof. So what does the first step say to do? Tell us to do. Somebody read that for us. Tony, what's it say?
It says assume temporarily that the conclusion is false.
Okay, so what is our conclusion here?
N is not even.
N is even. So how are you going to assume temporarily that this conclusion is false? Raise your hand if you think you know how to do this one here. Yes, Yachan, what are you going to write?
You have to think that N is not even.
So we actually have to use the words that they're telling us to use. We're going to actually, for the first step, you're going to write assume temporarily that n is not even. Is that okay?
Yes.
So that's your step 1. We just did step 1 now. We just assume temporarily that this conclusion is not true. Of course, when n is not even, what can n be? Since n isn't even, it's got to be an odd. So look at the second step. what does the second step tell us to do here? Nicole, can you read it for us?
Reason logically until you reach a contradiction of a known fact.
So what is the known fact in this? Yeah, n is an integer also, n squared is even. So we're going to, as soon as we assume temporarily that n is not even, we're going to reason logically so that we could reach a contradiction. Okay, by the way, what's a contradiction? Yeah. Huh? It's the opposite of what you're trying to say, right? So let's write down, let's reason logically. So we know that n is not even, therefore n has to be an odd number, right? Now, what happens when you then multiply n times n, which is n squared, isn't that right?
Yes.
So if you assume temporarily that n is not even, we know that n squared means n times n. What do you get when you multiply odd times odd? Like 3 times 5, what do you get? What about 11 times 3? Odd, right? Odd times odd is odd, right? So what can you say here? Odd times odd is equal to odd. Now, this is our step 2. We have reasoned logically until we have reached the contradiction to the known fact. I'm telling you right now, we have reached our contradiction. How?
Because we just
Raise your hand. How have I reached the contradiction to our known fact? Which known fact have I reached the contradiction of? Samantha? That n squared is even. Isn't this the known fact that they gave us? In given, right? We assume temporarily that n is not even, right? As soon as when we did that, we were able to logically reason, right? Reason logically that we have reason logically, and then we have reached the contradiction. Therefore, here's our step 3. But this contradicts, so you're gonna need to write this on the step 3. So for step 1 and 3, for step 1 you're gonna write this phrase, assume temporarily, whatever, and then you're gonna write, but this contradicts what? Given information. Which given information does it contradict? N squared is equal to even, right? We just said n, if we assume temporarily that n is not even, then n is odd, right? And odd times odd is odd. Therefore, we just have a contradiction right here. So therefore what? Now it says step 3, it says what? Point out the temporary assumption must be false. This is what we just did, didn't we? This is our step 3. And that the conclusion must be what? True. So now that we have shown that this given information is false, this then implies what? That n is even. Therefore, the temporary assumption is n is not even must be false, right? Therefore, it follows that n is even. Yeah. So when you do a indirect proof or proof by contradiction, it's sort of like a paragraph. It's not like 2-column proof. Does that make sense? So this, you see how you have 3 steps: step 1, step 2, and step 3.
But you said we'll never do paragraph proof. Yeah. You said we're only gonna do 2 column.
You said whenever it says do paragraph proof, do
Yeah.
We're doing now proof by contradiction. This involves some paragraph. So, all right. Any question? Yes.
do you write this?
No, you don't have to write this down. Yes, question. Right, not in this case. For this one, you do whenever you do this sort of proof, indirect proof, or proof by contradiction, you need to write this as a paragraph. Yes?
So when you like prove the contradiction, I mean when you like find the contradiction of the given information, then is what you're trying to prove automatically true?
Yes. That's a very good point. Nicole, what she says is correct. When we assume temporarily that the hypothesis is false, right, and when we then reason logically until we show that it is contradiction to the known fact, which is given, then this whole thing, then we have proven this proof. It automatically proves it. Does anybody see why? This sort of has something to do with what we did last time. Talk to your group. What do you guys think? How is this make this true? Proof true? Why? What do I think about it? So some of you were asking, for step 1, you need this phrase, assume temporarily. For step 2, after you reason logically, you need this phrase, but this contradicts the given information. Okay? And for step 3, what do you need? Therefore, the temporary assumption must be? Yeah. So so that's what you have to memorize. So you have to have these phrases for step 1, assume temporarily, and so forth. Step 2, you need that after you show logically, you need to show that but this contradicts the given information. And then for step 3, you need therefore the temporary assumption is false. Therefore, what we're trying to prove is true. Yes.
So is all the proofs only do steps?
Yes. 4 indirect proofs. But who remembers then? Who sees the? How is this related to what we did yesterday? Nicole?
Because it said that sometimes it's easier to prove like the contrapositive than the inverse or like the converse of the statement. So then this is basically like that. Like
Yeah.
you're proving the opposite and that's logically equivalent.
That's correct. What we're doing here is using the idea that the statement and the contrapositive are logically equivalent. What is a contrapositive of a statement if P then Q? If not Q, then not P. Where's the if not P part? Look at this 3-step. Where's the first step? Tony?
Well, for the original statement, I think the if n squared is even, then the n is even.
Right, so let's just look at these 3 steps. So, do you see how this is really related to the contrapositive, right? If I have if P then Q, look at what the first statement says. What's that saying? Assume temporarily that the conclusion is not true. That's the if not Q part, right?
Then that's contrapositive.
You see how we're doing if not Q here? Because we were assuming. And then what are we doing on the second step? Then we're showing it's not P, not the hypothesis, right? Then we're just stating at the end saying, look, yeah, since we have shown that it's a contrapositive, right? Then we're showing that the statement must be true. Because the statement and the contrapositive are logically equivalent. That's what we're doing here. That's the idea. Let's try the example 2. Look at this here, example 2. It says, prove that the bases of a trapezoid have equal length. You have a trapezoid PQRS with bases PQ and SR. They want you to prove that PQ does not equal to SR. So it's not like just writing a contrapositive, is it? It's actually working, right? After you assume temporarily that the conclusion is false, you have to reason logically, right? So that you could show that it is, no, it is what? It contradicts the known fact, which is the hypothesis. So to show you, that's the work that you got to put in. So what's going to be my first step? First step is always easy for these proof by contradiction. By the way, do you see why it's called proof by contradiction? Okay, it has to contradict. Okay, so what's my first step? Who haven't I called today? How about Chris? What would you say? Exactly. Assume temporarily. You have to use that phrase, okay? Assume temporarily that PQ is what? Equal to SR. That's step 1. Okay, now step 2 is actually where the work really takes place, right? Step 2 is the part where we have to show, right? Using logical reasoning, you have to show that you can reach a contradiction to the known fact. What's your known fact here?
Trapezoid.
You have a trapezoid. Also, you have bases PQ and SR, right? So you have to show that you have to reach a contradiction to the known part here. So what can you say next? If I assume temporarily that PQ is equal to SR, what can you say next? Any of you? Okay, go ahead, discuss with your group, see if they understand. How would you do this? Okay, so this is the work really, step 2, right? Step 2 is the part where you have to think about how you're going to contradict the given or known information, right? Known fact. So what are we going to say next here? How about somebody that have, how about John?
PQ is parallel to SR.
PQ is parallel to SR. Before you say that, you can't just say that right away, right? Okay, actually you can. Why? You're right.
Because it's a trapezoid.
Because it's trapezoid. Very good. So we know that PQ is parallel to SR because you have a trapezoid by definition of trapezoid. Very good. Then what, John?
And then we know that since PQ is congruent to SR, we know that. So
Because we were assuming that temporarily, right?
But that means that trapezoid PQRS is actually a parallelogram.
Right. Does that make sense? Because, why? Who remembers that theorem? We have now PQ equal to SR, and we have PQ now parallel to SR by definition of trapezoid. Nicholas, do you remember that theorem? Can you tell us what that is? What can we conclude? Quadrilateral PQSR is what? PQRS is? Do you remember the theorem, Nicholas? If you have a quadrilateral and you happen to note that the opposite sides are both parallel and congruent, what can you conclude? It's a parallelogram, isn't it? Do you guys remember that theorem?
Yeah.
If you have a quadrilateral and the opposite sides happens to be both parallel and congruent, what do we have? So that's what they're saying. We have a parallelogram, right?
It must be a parallelogram.
Right? Do you understand? So then what are you going to say next? So what? Have we reached our contradiction yet? To the given fact? By the way, what is our given fact? That we have a trapezoid with the bases PQ and SR. Have we reached our contradiction? Not yet. Go ahead, everybody talk to your group. How are we going to reach the contradiction? So what, guys? Who could tell me what to do? Justin, what do you think? Justin? What do you think? What is the contradiction here? So we have a parallelogram now, right? So where's the contradiction? Yeah, exactly. Trapezoid is not a parallelogram, right? Why? Because trapezoid must have exactly one pair of parallel sides. So there is your contradiction. It must be a parallelogram, and PS must be a parallel to QR. But what do we know? This contradicts that trapezoid must have only exactly one parallel side.
Wait, that's one proof? Jeez, you have to write the whole paragraph.
Yeah. Okay, then we're done with step 2. So step 3, what does it say to do? Point out that the temporary assumption must be false. So what are we going to say now? Who could tell me? Yes.
Then PQ can't be equal to SR.
So you have to actually say it this way. The temporary assumption. What was our temporary assumption? PQ is it must be false. Isn't this what we just said?
Yes.
Because if they were, then you have a contradiction. You have a parallelogram instead of a trapezoid. Therefore, what? Yeah. Therefore, what we wanted to prove in the beginning is true. That PQ does not equal to SR. Does this make sense?
Yes.
So let's summarize what we just did, and this is what we were talking about in terms of the contrapositive. Who would like to read? Can you see how? Okay, this is, yes, go ahead, Esther.
Can you see how proving a statement that proving is contrapositive is related to indirect proof? If you want to prove the statement if P then Q, you could prove them contrapositive if not Q then not P. Or you could write an indirect proof. Assume that Q is false and show that this assumption implies that P is false.
Okay, do you see how they are related this way? Okay. The work is showing that this part, right? The second part, where you reason logically until you reach the contradiction to the known fact or given fact, right? Let's do a couple more, okay? Okay, write this down, and I want you to write an indirect proof in paragraph form. Given that measure of angle x does not equal to measure of angle y, prove that angle x and y are not both right angles. And of course, this is sort of obvious, right? Of course, x doesn't equal to y. They're not both right angles, right? But this is sort of practicing how to use this indirect proof. See if you can do this. All right, who can tell me what our first step should be? Brandon.
You say x and y are right angles.
Yeah, but you have to use that phrase. Assume
Assume that x and y are variables.
temporarily that.
That angle x and the y are both variables.
Correct. Okay, now that's our step 1. And when you do your homework, I think it'll be easy for you to sort of list these steps, right? So that you don't forget any of these steps. So step 1 is here. What's step 2? What are you going to write for step 2? We need to now reason logically until you reach the contradiction of the known fact, which is that measure of x does not equal to measure of angle y. You better? They're what? No, we're assuming that both x and y are right angles. So then what can you say next from here? Yeah, so if I assume x and y are right angles, right? What do you know about angle measurement of angle x? It's 90. What's measure angle y? So if they're both 90, guess what? They're both congruent. So if we assume temporarily that x and y are right angle, we know that angle and both of these angles are congruent, right? Or equal. Measurement are equal, right? So then, Iveta, do you see the contradiction to the given fact? Now there's your contradiction, correct? Step 3, then you say this contradicts what? The given where measurement angle x does not equal to measurement angle y, doesn't it? So therefore what? The assumption that measurement angle x and y are right angle is false, and so therefore what have we proved? Angle x and angle y are not both right angles. Does this make sense?
So is that how you write number 3?
Yeah.
Wait, but what? Can you say?
So step 3 should really start from therefore.
Yeah.
Right down here, right? It's therefore.
Oh, I get it.
I get it. Okay. Do you guys get the idea?
Yes.
Let's do one last one. Alright, try this example now. Next one. It says parallelogram XYZW. That's what you have, and measure of angle x is 80. Prove that parallelogram XYZW is not a rectangle using the proof by contradiction. Go ahead, everybody try. Good. Yeah, exactly. That's what you're going to start with, right? Go ahead, everybody try. Did you say, assume temporarily that XYZW is a rectangle? Okay, then what can you say? If it's a rectangle, you know all the angles are? 90. That's a what? Yeah. But that contradicts the given information that measure angle x is? 80. 80. That's the given. So therefore what? Therefore the assumption is false. And so this is not a rectangle. Any question? Do you guys understand? Okay, good. Go ahead, take your time.